Alright, this is Mr. Gillum, and today's the big day we start earning Pokemon. So, Khan Academy assignments that I post out there, you can start doing those, as well as the Study Island assignment. This is going to help you move towards Zubat, Golbat, Nidoran, Nidorino, and Nidoking. So, the better you do at the Study Island, the more opportunity you have to win these Pokemon for your Pokédex. So, it's a big day today. Basically, what the Study Island assignment entails is dividing fractions and solving word problems involving division of fractions. Now, I pulled several of the problems that are in the Study Island that I thought might be challenging, and so I'm going to do a few examples. Now, your problems might not have the same exact numbers, but they will be similar. So this might help you reference how to do well on your Study Island without having to do it 10 times. So the first question here says that Martha is making a recipe that requires 2/5 of a cup of sugar. She only has 1/3 of a cup of sugar at home though. What fraction of the recipe can Martha make with the amount of sugar she has? One of Mr. Gillum's strategies when solving word problems is to make the numbers more reasonable. So let's just pretend that in green I'm going to change 2/5 to 6, and instead of 1/3, let's say she has 2 cups. Now, this problem will be much easier, and I'm sure everyone could solve this one. It says that Martha is making a recipe that requires 6 cups of sugar. She only has 2 cups of sugar at home, though. What fraction of the recipe can Martha make with the same amount of sugar she has? Well, to me that says, well, she has 2, but she needs 6. So she has 2 of the 6 cups that she needs. She has 2 of the 6 cups that she needs. So if she had 6 cups up here, she would have 2 of them, right? So she would have 1/3 of the amount that she needs, right? She would be able to make 1/3 of the recipe. Unfortunately, though, the numbers aren't that easy. What we have really is she only has 1/3 a cup of sugar, but she needs 2/5 of a cup of sugar. So instead of using these green numbers and solving the problem, let's change the green numbers back into the numbers that are actually in the problem. Really what she has here, she has 1/3 and she needs 2/5. Now, notice how I really emphasize that really long fraction bar there. Okay, she has 1/3 of the total amount, 2/5. So we watched a little video on how to separate these compound fractions into a division problem. And so what we're going to do is we're going to change that to 1/3 divided by 2/5. Okay, if you're forgetting that we did that, I would go back and I would reference that video. We did a bunch of examples on how to change that into a division sign. So we have 1/3 divided by 2/5. So now we can do this, fraction divided by fraction. Remember, the steps start with 1/3 multiplied by the reciprocal, 5/2. And so now I would look and I would think, okay, well, is there anything to reduce? 1 and 3, 5 and 2, or cross reduce 1 and 2, 3 and 5. And in this case there is not, so I would multiply straight across, 5 over 6. So what we could say is that Martha could make 5/6 of the recipe. Okay. So I thought that would be challenging, and I think I got another one that's kind of similar to that on here. This guy's name is Topher, and he has 2/3 of a whole pizza. How many 1/6 of a whole pizza are there in 2/3 of a whole pizza? Wow, that sounds really confusing, but once again, it'll be much easier if we change some of the numbers. So again, I'm going to go back to my strategy here, and I'm going to say, instead of having 2/3 of a whole pizza, I'm going to circle this in green. Let's just say he has 2 whole pizzas. And instead of saying how many 1/6 of a whole pizza are there, let's say how many halves are there. So I can think of it this way. If I have 2 pizzas, I want to know how many halves there are. I have 1, 2, 3, 4 halves altogether. Or I could think of it as, well, I have 2, and I'm dividing it into halves. So I could change that to 2 times 2 equals 4. So I could visualize it and I could think of it that way. Now the nice thing about writing it down this way is that I can replace the 2 and the 1/2 with my actual numbers. If he has 2/3 of a whole pizza instead of 2 pizzas, and he wants to know how many 1/6 will go into it, then I can go ahead and I can do my division here. I'm going to change it into 2/3 multiplied by the reciprocal, 6/1. I'm going to check to see if I can reduce, cross-reduce 2 and 1, or cross-reduce 3 and 6. 3 goes into 3 once and into 6 twice, and then multiply straight across. Oh, hey, that is just completely coincidence, boys and girls. I just made up those random numbers, and it happened to be that way. So just because the green numbers work the same and we got the same answer, don't think that always happens. That was completely luck. So in this case, though, I do know that there are 4 1/6 and 2/3 of a whole pizza. So when it asks me how many 1/6 are there in a whole, there would be 4 1/6 slices. Not 4 and 1/6, 4 comma 1/6 slices. Or you could just put slices if you would like. In fact, I think the 1/6 is going to be confusing. Okay, just 4 slices. And I will know that you're talking about each slice is 1/6. Okay, so again, let's go to the next one here. Jack lives on a farm and has a large backyard. The area of a rectangular backyard is 2/3 of a square mile. If the width of the yard is 3/4 of a mile, what fraction of a mile is the length of the rectangular backyard? Wow, there's a lot of reading. Okay, again, I see fractions. I know that this problem would be so much easier if they didn't put fractions in there. So I'm going to use some numbers to make this a little easier first. The area of the rectangular backyard, let's just say it's, let's go with 12. The area is 12. And the width is, we'll say 3. We'll just say it's 3. What fraction of the mile is the length of the rectangular backyard? Okay, so to solve this problem, you have to have a little bit of background information on area. And it says that he has a rectangular backyard and that the area altogether, we change it to 12 altogether. And so part of the problem is you knowing that area is the length times the width. All right, and in this case it says the width is 3. Well, if you know that the area is length times width and the width is 3, that would make the length have to be 4. Or you could think of it as 12 divided by 3 equals 4. Okay, 3 times 4 is 12, or 12 divided by 3 would be 4, the missing part. All right, so now that we know kind of how this would work if it was actual real numbers, and I should think I'm going too fast. Length times width is the area of a rectangle. If the total area is 12 and the width is 3, I know that 3 times something would have to be 12. That something is 4. If I wasn't thinking of it as 3 times something equals 12, I could think of it as, well, 12 divided by 3 has to be something, right? Or 12 divided by 3 has to be something. So I would know that the solution is 4. Well, unfortunately, again, those aren't the real numbers. The real numbers are 2/3 is the total area, and we want to know what the length is, and we're going to figure that out by dividing by 3/4. So again, I'm going to change this to 2/3 times 4/3. Remember to only reciprocate or invert the second fraction. Division changes to multiplication, invert the second fraction, reduce, reduce, cross-reduce, cross-reduce, 2, 3, 4, 3, nothing changes, and then multiply. 8/9, multiply straight across. 8/9. So what fraction of a mile is the length? 8/9 of a mile. 8/9 miles. Okay. And finally, there's just a couple models here that I want to show you. And these are a little tricky. We did something similar to this on a worksheet already, but I want to show you again. It says use the model below to find 1/2 divided by 2/3. So what they did is they only shaded in the 1/2, okay, which can be confusing because we did 2 types of shading. Here's how we're going to do this. If the model is shaded in 1/2, I'm going to shade that in red. Okay, and then it also divided the model up and down into thirds. Now here's the tricky part. 2/3 would be those 4 right there. I'm just going to put dots on them. Those 4 green dots would be 2/3. Now, when I say those 4 green dots, that's really, really important, because I know that if I'm trying to figure out how many times 2/3 goes into 1/2, it takes 4 squares to get into, we're trying to squeeze that into 3 squares. So there's 3 reds and 4 greens. So unfortunately, 2/3 won't fit into 1/2 even one time. It'll be less than 1 because 2/3 is bigger than 1/2. So the way I'm thinking about it is I need 4 rectangles, but I only have 3 of the 4 rectangles that I need to fit into 1/2. So my answer would be 3/4. All right, and of course you can always check 1/2 times 3/2 would be 3/4. So again, they have modeled 1/2 and divided it into 2 pieces, and they've also divided it into thirds, but it wants you to represent it 2/3 is what we're representing. So that's 4 rectangles. Now we know that 2/3 won't even fit into 1/2 once, so we should have a fraction that's less than 1. It takes 4 to be a 2/3, and it only takes 3 to be a 1/2. So 3 of the 4 pieces of a 2/3 would fit into a 1/2. So we get 3 out of the 4 pieces, 3/4. And I want to do another one like that because I know those are a little confusing. It says use the model below to show 3/5 divided by 2/3. So we have 3/5. So we divide it into 5 pieces up and down, and they shaded in. They did a nice job of shading 1, 2, 3, all these 3/5, right? And they also divided into thirds on the side. But again, I want to show you that we're not just talking about 1/3, we're talking about 2/3. And so I'm just going to put dots on those 2/3. The 2/3, they divided into thirds this way, will be every single one that has a red dot on it. And it's hard to see the red dot, so I'm going to go back to green. All those. Now, what I need to do is I need to count to see how many squares there are in 2/3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 squares in the 2/3, and there are 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 squares in the 3/5 of my model. So in this case, we actually are going to fit in. I need 10, but I only have 9. So what I'm going to say is 9 of the 10 pieces are going to fit in. Okay. Again, 3/5 is less than 2/3, so I know I should have a fraction. I need 10, but I've only got 9 to divide it into, so 9/10 of the way. All right. Let's see here, how could I explain that again? I have these 9, but I've got to fit 10 into it, so only 9 of the 10 pieces fit. So 9/10 is my solution. I hope that helped. Again, you can always check 3/5 times 3/2, multiply straight across, 9/10 is the answer. So always double check your work, boys and girls, and that should be a good start on your, I think I entitled it 6.NS.A.1, something along those lines, your study island. Those are some examples on how to do it. Go ahead and get started right now.